Often, electrical circuits are connected to the earth or ground. Buildings have a metal spike deep in the ground that the middle pins of your power points are connected to. It can be considered as an infinite reservoir that electrons can flow into or out of, depending on what is connected to it. It's the reference point for neutral or zero electrical charge. And this leads us to our final way of charging objects, by induction. This means that you have induced electrons to move in an object without touching it. It works like this. Initially, you have a metal sphere that's neutral. Hold a negative charge near it. Electrons in the sphere move because they feel a repulsive force away from the rod. They congregate on the other side of the sphere. If at that time a wire connects the far side of the sphere to the ground, electrons will run from the negatively charged side of the sphere down to the ground. Now remove the wire, still holding the rod near it, and finally remove the rod. Electrons have been removed, so the sphere is left with a deficiency of electrons, which means it has positive charge, which is evenly distributed around the sphere. The electroscope was one of the earliest devices to measure electrical charge. It consists of a metal plate at the top, connected via a metal rod to thin metal leaves inside the jar. Bringing a positively charged rod near the top plate makes electrons run up from the leaves to the plate. The leaves are now positive, and so they repel each other. They're so lightweight that they move apart. The version on the right is a bit more sophisticated and has only one leaf free to move, with a scale at the side to measure the amount of separation. So using that, you can put a number to the amount of charge.